Hi, I'm Frodo.
And I'm Sam.
Would you want to go on a magical adventure?
Yeah, let's go.
Sweet, yeah.
Oh wow, where are we now?
We're in the world of adding and subtracting.
Oh, do you know anything about that?
No, I don't. Can you explain it?
More than likely. Okay, so what you do is you take the h of x is equal to g plus f plus g of x, aka the sum of the two numbers together is h of x. So if we look at this nice little table that just magically appeared, we have the x's, which is 0, 1, 2, and 3. And then if we do something to the x's, and we're finding the y's now, just so you're aware. So we have x minus 2, so we have now the x's are negative 2, negative 1, 0, and 1. And then we have in the g of x's, which is x squared, we have, which is x here, we have x is 0, 1, 4, and 9. And then when we add them together, we have from the f of x column and the g of x column, if we add them together, we have 2, 0, 9, or 4, and 10, sorry. So that would make the domain of this equation, which would be h of x is negative 2 plus x squared, is the domain is any real number. Did you get that?
Yeah, I did.
Okay, and now for subtraction. It's pretty much the same thing, except for instead of adding to find the answer of the two numbers, we would subtract them. So for this equation, we'd have that like that. However, you have to note that if f of x and g of x are both equal to 0, then that would, or are both the same, that would make h of x 0. And the domain of h of x is x plus 2 minus x squared would be the domain is any real number.
Yay, I get it now.
Yay! That's it.
Whoa, a whole new world.
Whoa, where are we now?
We're at products of functions and quotient functions.
Whoa, what's that mean?
Well, I'll explain it to you.
Okay, thanks.
Alright, the product of functions, we're right here, we're f at x equals 0, then g at x equals 0. And where f at x equals 1, it equals h at x equals g at x. And where f at x equals negative 1, h at x equals g at x.
That's cool.
Yeah, so for the domain of h at x is the intersection of f at x and g at x. So we're going to look at an example. So when f at x equals x minus 1 and g at x equals x plus 1, we're going to find out what h at x equals. So we see that h at x equals f at x times g at x. We sub in x at x minus 1 for f at x and x plus 1 for g at x. And we solve. So we rainbow and we find out that h at x equals x squared minus 1x plus 1x minus 1. And then taking common factors, we find that h at x equals x squared minus 1. So now we can sub in, for example, to find out what h at 5 equals. So we sub in 5 for x, and when we do the math, we find out that h of 5 equals 24. So now jumping over to quotient functions, when two functions are combined in a function, they are called a quotient. Example, when a g at x is matched with f at x, f divided by g equals, times x. So any given value of x is represented by f at x divided by g of x. So here is it shown algebraically. So if f at x equals 0, f divided by g times x equals 0. Do you understand now?
Yeah, thank you. That was great.
Holy smokes, where are we now?
We're in the world of composite functions. Do you know what a composite is?
No?
Well, a composite function, as it says over here, is a function inside another function. Like this, where it shows that h at x is equal to f at x with g at x inside of it.
Okay.
You can find the domain of a composite function by finding out what the domain of g at x goes to solve for the range of g at x inside where it overlays with the domain of f. And then the range is the range of f. These solve to make the domain and range. You can solve these composite functions easily, even though they look complicated in real life, through using your TI-83 calculator. The way you do this is by hitting second function and then trace, and then following the on-screen instructions. Does it make sense now?
Yes, you're really smart.
Thanks, I know.
Wow, I learned a lot about composite functions.
See how easy it is to be smart with videos? Yeah,
Yes.
let's party and dance.
Woo!